Good afternoon, everybody. This is Robin Ayub from the Localization Fireside Chat, and welcome everybody to another episode. Today we are recording episode 104, and I'm honored to have with me today Dr. Sidney Shapiro. Dr. Sidney Shapiro, he is an assistant professor of data analytics and data science manager. He works at the Dillon School of Business at the University of Lethbridge in Alberta. Thanks, Sidney, for coming to the conversation, for taking part of this conversation, this dialogue. I really appreciate your time, and I'm looking forward to our conversation.
Thank you for having me.
Absolutely. One of the things that we start the conversation with here on this podcast is to tell us a little bit about yourself. You know, what led you to where you are career-wise, and what something interesting that happened that triggered it, or is it just the typical, I got driven to it by incidents around me, or my environment took me to it? Go ahead. The floor is yours.
I like to tell students that when I was in school, my field didn't exist at the time. And the work that I do now is not at all related to what I studied. But when I was in university, in both my master's and my PhD, I really looked a lot at social research, especially large-scale data analytics. And that kind of led me to doing data analytics as a job. Eventually, I worked on a program to build out business analytics, and that led me to here. So I think that even though we might not call it the same thing, every organization has a lot of data, and they have to figure out what to do with it. So that's kind of the commonality in all those different pieces, like trying to make better decisions using data that you already have.
Absolutely. And tell us a little bit about the program that you teach in. I'm not familiar with, to be honest with you, before we got introduced online, I started doing some work researching on the institute, the Dillon Business Institute, which is, I think, part of the University of Lethbridge. Is that an arm of the university? Is that it?
Yeah. So it's the business school of the University of Lethbridge. And in the program, we have many different courses that look at the intersection of business and computer science. So essentially, every organization has data, they have systems. And the question is, how do you put those together and make them work? From looking at things like millions of transactions in accounting to financial management to auditing, all those pieces come together, especially because systems that companies run are becoming more and more technological. So now they involve databases, now they involve data, now they involve enterprise infrastructure, and all those pieces come together in the various courses I teach, whether it's SQL or Python or Excel, or just the underlying analysis of what data do we need and how do we build ETL pipelines to bring things together.
So what do your graduates, your students, they graduate from the institute, what degree would they have? What do you call that degree?
So many of the students that I teach are in the Masters of Management program or the Bachelors of Management. We also have students that are taking a data science certificate where they do that on top of the degree they already have. And those students come from across the university. So I've had students in nursing. I've had students in English. I've had students in many different departments who are interested in how to bring those pieces together. And I also have a lot of students from computer science. So it just depends on what their background is, whether it's interest in building apps, using data, building pipelines, and all that comes together when we're putting together, the process of how to work with data.
Absolutely. I just came back from, you reminded me like this whole management of data. In the 80s, when I did my computer science degree, my specialization was in French, we call it informatique de gestion. So managing the information for businesses, that's what so for many years now, this topic has been, on the back mind of many academia, I guess, and trying to put it together in a formal way, basically make use of technology for the purpose of business. That's what's decision-making or any other type of business. I'm assuming this is where you're heading with this, right?
Yeah, so the question is, where does that functionality live? And I think over the past maybe 20 or 30 years, we've seen it go back and forth a lot between the IT department, the accounting department, management, and operations, depending on who has access to the data and what they're doing with it. Now with modern technology, which means Excel, databases, AI, etc., people who are in operations, for example, can make decisions using data without having input from many, many other people who are the key holders over that data, which means that it's really transforming how business operates. And you see this both at the big scale, as well as an entrepreneur who now can leverage 20 different tools together to build out amazing things, but run the entire company in all the different aspects from coding to billing by leveraging other tools.
Absolutely. And if you can give us a little bit of a picture on the Institute itself in terms of how many students you work with on a yearly basis. Are they local students or are they international students? Do you have like an online programs? Can you talk a little bit about those?
So the University of Lethbridge has about 10,000 students overall, and we have campuses in Lethbridge as well as in Calgary. We have both students in person and online, and we have domestic and international students. It just depends. I work a lot with graduate students. In graduate programs, there's fewer students that work on research or a thesis. I work on a lot of my tax projects, so we get funding to work together with industry, and we leverage funding in order to hire student internships to work on projects. Through that, we've built apps, we've analyzed data, and built systems for companies. A lot of times companies have an enormous amount of data, but they need to have something to do with it. And usually that comes down to helping students along this career trajectory of sitting down with a company and saying, what tools do you have? What data do you have? How can we put that together? And it's really nice that there's these opportunities through the university. University of Lethbridge tries to get work placement or like hands-on learning for every student in the university in every program, in business and computer science especially so. So I think that there's a lot of really fantastic opportunities working with not only local companies, but I've worked with companies across Canada who have taken advantage of these programs.
I was going to ask you on career placements, because it sounds like to me like you could do a co-op program with some of your students in terms of placing them in businesses to practice what they've learned and or put it into production, if I was to use a business term for it.
Yeah, so we do. We have placement courses. We also have work integrated learning throughout the courses in the program. We work with a company called Ripen, RIIPEN. That's a workplace database of connecting schools and industry. And there's many others. Many of the projects that I work with, I happen to meet a company and say, I could help you with leverage. We could supervise the project, and then it has to be a win-win between the students and of course, at the same time, many of these projects also have a research component, like what actually is happening under the hood. I worked with a student recently to write a very interesting paper that's now under consideration, looking at market making versus market servicing for quantum AI. It's quantum technology. It's a very new field. It's something that people don't really understand, but still companies have to service and market it. And this gives an opportunity for students to be involved in emerging technology, as well as have an opportunity to write a paper. And I think that's really fantastic because, the interesting thing about universities is you could take as many courses as you want, but you never take a course watching somebody how to write a paper. And ultimately, papers is the currency of universities. So I think publishing and sharing your ideas and becoming a voice in the industry and really understanding what those pieces are is really critical to a student's progression, especially for graduate students.
Absolutely. You bring up a very good point. For those in the audience, whoever you have kids and your kids are asking you, hey, what am I learning math for? What am I going to use it for? In this case, you're answering the question, what are you going to use it? You're putting it into action.
Right. Exactly. And I think that in this field, in computer science, as well as in business and the intersection between them, I think it becomes very obvious of when you have to use regression, why you'd want to find out, how you cluster your customers. Every business has churn. How can we address that problem of, do we get new customers or would you try to service old ones or some combination in between? So I think that getting back to fundamentals and having that pathway to understanding it is really critical. Right now, there's a lot of focus on AI. The problem is that AI is kind of a high-level concept, and if you don't have fundamental skills, you really can't tell if you're getting the right answer or if it makes sense, or at what point do you just, turn over the keys to AI and say, let's build a pipeline to automate this process. You don't want it to automate at scale and be wrong. So that's why it's really critical to have those pieces aligned so you have fundamental knowledge, which is why even though AI can program, it still can't do what your brain can do, which is think. And I really try to emphasize that in classes, that students need to understand this AI partner that they're working with, what is actually happening.
And I was in Montreal. I just came home from two conferences, and we talk a lot in those two conferences about languages, propagation of communication between demographics, and how languages are enabling connection between a variety of reasons, marketing, business related generally, or for more human-based communication, like immigration, religious, whatever the case may be. Instead of having communication that it's a barrier, now you have an enabler. And in the language industry, the industry itself is going through a huge amount of transformation, specifically on AI. You don't flip a channel or TV or YouTube anywhere unless you hear something about, this industry's gone because of AI. And we keep saying, no, as you mentioned earlier, you still need a brain of a pilot to run you can put the plane on an autopilot, but you still have to have a backup for that. And the backup is the professional, which you mentioned earlier, the programmer, the brain, etc. Brings me to a topic that it's always been on my mind in terms of, you mentioned data. And a lot of businesses, translation business or the localization business is one of them, where data, sits in a static format, meaning it goes into a terabytes or, gigabytes of data, sits in a hard drive somewhere. It's not doing anything. It's not actualized. And then, we're trying to make decisions out of that because there's a lot of value in that data, but we're not accessing the data. Or if we do access the data, it's a nightmare to find a way to access it in a, systematic way that can enable us for valid output out of that. What's your thoughts on activating non-active data, if I can use a simple term for that?
So I've worked on a few translation projects that use AI, and a lot of it comes down to the ability to have context. I worked with one client that was translating word by word. So if you take like a 20-word sentence and you translate it literally word by word, you get back something that doesn't make any sense. In fact, later on this month, I'm giving a talk about students cheating. And what they do is they take the English essay, they convert it to another language and switch it back, and it's totally different words, and it kind of means the same thing, and it's plagiarism free. So I think that type of translation is a big challenge, and Google Translate has been doing that for many years. With AI, we're able to take paragraph by paragraph or page by page and understand both what the context is as well as regionalization, and start having more direction. But really, to understand, does this make sense? Does it make sense in context? You have to have domain expertise. So I think that even though we could build pipelines to take all this massive data and start pumping it through, the question is it actually good when it comes out on the other side? And to judge the quality, you really have to be an expert. I recently published a paper on parenting with 3 professors who are parenting experts. They've written parenting magazines for a very long time. You could find these flyers in doctor's offices when you go to find out about the age of your kid. We asked ChatGPT all these standardized questions that a professor would normally answer in these sheets. And we found that 80% of the time, it gave you accurate advice, probably because it was trained on their data at some point. The problem is that for 20% of the time, it gives you the wrong answer, which is really terrible, and we don't want that to happen. So I think that there's this back and forth between understanding the context as well as the translation itself, and building confidence in those pipelines, which really means having a human read it over to verify and make sure that it makes sense.
So you're in the camp that says, this has been debated quite a long time now, for the past couple of years at least, that you always need a human in the middle. Now, the definition of a human in the middle, it's being debated as well. Like, is it a computer science graduate, or is it a data scientist, or is it the professional themselves, whatever they happen to be in this case, a parenting expert, or a translator, or somebody else. So you're in that camp of thinking, I'm assuming.
I'll tell you a couple different examples. The first one is, walnuts. When, you want to open a walnut, we need some kind of tool for it. The thing is, if that tool doesn't work appropriately, like a nutcracker, do we build a sledgehammer, a bigger sledgehammer, a bigger sledgehammer? This idea is scaling out of problems. When Google tried to do this, Google, unlike OpenAI ChatGPT, has less input and feedback. So when they started making automated returns on their search engine, if you asked it how to stick the cheese to a pizza, it said, obviously, glue. Now, the reason why it said glue is because stickiness is associated with glue and stickiness is associated with cheese. So it must mean that those things go together, but that's not true. In other words, you need a person to say that that's not the case to retrain the model to be more accurate. So when we have large amounts of data that simply don't make sense, or that they go together in theory, but there's no logical reason why, then we need a person to tell. Now, what happened with Google is Google built an oppositional model called red teaming, where they have a model that checks the first model and basically goes back and forth to improve it. The real underlying idea is, can we scale out of problems by building a bigger model? The problem with this approach is that, yes, the model, the second one, might catch that cheese shouldn't be stuck together with glue, but then the next problem it's not going to catch, and you'll need a third model to correct the second model that corrects the first model. So without somebody making a common sense decision, like, here's how you put cheese on pizza, ultimately we're going to get into these rabbit holes that are very expensive in terms of processing, are extremely computationally expensive and complicated, but ultimately mean nothing because anybody can tell you the best way to stick pizza on cheese. So the problem is that if you extend that to every possible human knowledge, we're quickly going to get to the point that some things are associated with other things. They have a very strong association, but they can't actually prove them. And that's what happened last year with strawberries. People said, how many R's are in strawberry? And if you just write it down, you can count that there's 3, and you could come up with that in 1 second. The problem is that in the English language, the word strawberry and the number 3 aren't associated with each other. So if you try to pick out a number, they're not connected. And that's why it can't mathematically solve that problem, because it's not a language problem, it's a counting problem. And that's something that anyone can do really easily, but it might not be a generative AI problem unless specifically trained. If you think about it, every time we have to custom train a model, and that gets more and more complicated for every single problem that comes up that they're not associated by language, we're literally going to be solving endless problems. So building the model is not a big deal, but fixing the model could take forever.
So you bring a very good topic, though, Sidney. It's been debated around quite a while now. I've heard this conversation all over. Evidently, you're putting together the case for, you need to train the model. You cannot use the free version that is out there and, take the cheap route out. It's not like downloading an app and putting it on your iPhone. This is a little bit more, very well thought out process to implement these things. And it's not like checkbox to the, I've got AI, I bought it, it's $20 per month and everybody's using it in my organization. I solved the problem. Am I correct? It needs to be well thought out to be deployed.
Well, the model is always based on the data that you already have, which means that if you're putting in garbage data or you have problems that don't make sense, having AI is not going to fix it. Although AI can sound very authoritative, it could still give you the wrong answer based on your data. We always have this issue, like for the past 40 years, our organization's been very biased. Now we're using AI and it seems like it's not biased anymore, but of course it is because it's using your data. So I think that, you really have this problem that implementing an AI system, yes, it could solve some problems, but it may not be an AI problem that you're trying to solve. And I think that's the big challenge, understanding what's a machine learning problem, what's an AI problem, what's an Excel problem. And picking those tools really helps you. Like, it's just like if you hired a plumber, but the plumber only had one screwdriver and nothing else. Sometimes you have a wrench problem, not a screwdriver problem, and that's just not the right tool. So, and if you look at the difference between the $20 model and the $200 model and the $2,000 model, and there's all different variations, having a more expensive tool doesn't necessarily fix the problem. It might actually be a totally different problem that you're trying to solve. So having that domain expertise to understand what problem are you trying to solve and which tool is most appropriate is a critical first step, because otherwise you're just mismatching the problem and tools and you're never really going to get the right answer.
And hiring the expert will be number one step, I guess.
Exactly.
And in our world, in the translation world, we deal a lot with old technology. Well, technology is evolving so fast. Old technology of yesterday, it's old today. So we have a lot of repository of data. We call them translation memories. And those translation memory is what previously has been translated, collected together into segments and, paralleled together with the language combination that you're trying to translate to. Now, are they perfect? No, because they were developed by a human. Translator has coded them, or for the lack of a better word, translating them, and that translation output found its way into the memory. And, one of the biggest thing is that, a lot of people, like they're doing right now, is they're taking their translation memory, feeding it to the models, to the AI model, and hoping for the best, basically. And what we're saying is, hey, before you feed that memory over to the model, maybe it's time to check the memory, make sure that your terms that you used 10 years ago still apply today, because language evolves, and you may be using some terms that 10 years ago were acceptable. They're not acceptable today, specifically when it comes to gender neutrality and all that biased terms that existed 10 years ago. We don't want them to exist now by policy, probably. and you want to clean it up, or you may have errors in there. So, human make errors. That's another thing too. Like AI makes error, of course, and a human makes error too.
So one of the biggest problems with this topic is that AI, we're not really sure why it's making the decision it's making. And I'll give you a really simple, narrow example. If you walk into Tim Hortons, which is a popular Canadian coffee store, and you say, I'd like to order coffee with, what's the next word? The next word could be anything, but it's probably going to be one of 10 things, one of 20 things. There's honestly not that many ways you could order your coffee. It's not like the infinite world of possibilities. It could be one of 10. And if you had to pick, is it sugar? Is it cream? Is it double-double? Is it something else? Is it Tinbits? There's probably going to be a most likely choice that most people choose, and that becomes the strongest connection. Now, the problem is that inside of AI, generative AI, it's a black box, and we don't know which one is picking. We don't know which word is more heavily weighted than another, and that's the reason it's picking it. So although we could feed in a translation database into this big model, it's still making choices that we can't backtrace and find out why it picked that particular option. Why not another one? Maybe we should change the model to more be biased towards one choice or another. Like you're saying, maybe there's particular reasons, like policy, that we'd want to pick one word over another. Now, in order to fix this problem, there is a technology called Explainable AI. In other words, to trace the pathways in the model, that could cost 20 to 200,000 times more than we're currently paying in terms of computation. So although you could do the $20 a month, nobody's going to spend the $200,000 a month to actually trace every single choice and figure it out. So right now, when we get back a translation or we get back an answer, we're saying, okay, it's good enough. But why does it really happen? We don't actually know. Unless you build the tokens yourself and actually figure out which words are more weighted towards the answer that you want over another. Now, this technology is happening in some contexts. Like, for example, there's new fingerprinting technology that they're going to pick words on purpose to be like more biased so that they could prove that that text was generated by AI. So for example, you say, I'd like coffee with cream. Cream is going to come up more often than sugar. And if you see that example among millions of pieces of text, you could trace it back to the original model. That fingerprinting idea is very computationally expensive, very complicated, and may not always work. Really, to actually trace back to a model, you need pages of data, not just a few sentences.
So moving along the conversation here, I want to ask you, because there's a lot of talk about Canada's AI policy from a policy perspective. And, we live in Canada. Obviously, everything is influenced by government to a large extent. They set the directions, the policy on every aspect of things, which is, I guess that's the natural thing here in the country. Wondering from your perspective, where is Canada stand on AI from where you stand, from where you sit in your capacity? What's your read on that?
So there's a few very interesting things about this AI revolution, although parts of it were founded right here in Canada, including in Alberta, in Edmonton, at University of Alberta. There are problems that most of the computing capacity that exists for AI is in private companies in the US. So we don't necessarily even have access to it. There's people who are using AI as a research object, so they're researching AI systems. There's also people who are using AI as a research tool. But in both of them, the computing hardware that exists, we're not really there. In fact, you could say we're billions of dollars behind. Universities in general, including in the US, are behind what private companies have built. In terms of what we can do with AI, I think that there's a lot of different possibilities and how we could put those together. From a policy perspective, we have to make a decision to invest in this technology because it's going to have huge gains down the road. And that's a policy decision that requires a lot of money in order to catch up. And I think that's one of the big challenges. So for some of my research, I'm using the $20 a month, the $200 a month version. I'm also using the API to run experiments at scale and using actual computing resources that are in Canada. So we're able to do that. But there's certainly not enough capacity to truly build out something gigantic. In terms of the industry, there are tons of AI companies in Canada that are building really interesting technology. And I think that's a competitive space for us to be in, especially as AI education is getting larger and larger across the country.
And so am I to conclude out of this that, the AI available now, AI technology is available now, is pretty much outside of Canada?
For most of it, it is, but we are building data centers. We are building more capacity. I mean, you have to realize that one of the critical things that we talked about earlier is that AI currently doesn't run on our devices. There's no chip in your phone that really runs AI. AI, for the most part, is run in a data center. Now, why can't I go to my microwave and press a button and say baked potato and it says 6 minutes? Now, if the word baked potato was associated with 6 minutes and lived on a chip inside my microwave, you could understand that that technology would be really easy to implement, and it would require an LLM that's relatively small, and it would know every food that I could possibly want to microwave. Just like I could talk to my car, just like I could talk to Siri right now. The problem is that we currently don't have those chips yet, but we will in the future. And as AI models become smaller and faster and more powerful, we could build the hardware to match this massive acceleration that we've had in software so that AI can run on our local devices and understand us better. We can communicate with them in natural language. In certain respects, this is already happening in programming. It's happening in image generation. It's happening, but we have to move away from data centers, which are currently being built everywhere, including in Canada, to more localized versions, which will be faster and easier to run. And that's like what the recent models that have come out of China have done, where it runs faster using software instead of faster using deployed hardware, which I think is going to change the infrastructure over time.
So are you in, can you comment on the idea, like right now, like in Canada, there's regulated and non-regulated industries, and the regulated industry that love to have everything behind a firewall, Sidney. So what's your idea, or what's your thoughts on behind a firewall deployment and public deployment with a scrutiny attached to that?
I talked to a company about that this week, and it's a big challenge because if you have sensitive data, like for example, medical records, and you're deploying a local AI solution that needs to be upgraded over time and retrained and explained as things change, you can do that, but you have to have the IT infrastructure in place to do that. The reality is that most businesses in Canada are still using Excel. And now they're trying to do this quantum leap between Excel suddenly into AI. But in between, there's a data normalization, databases, technological maturity. You have to have people that will be the champions and help you put this together to actually make it run. And that currently in many businesses doesn't exist. So that's the big leap, trying to find out how can we take our operations and move it into AI in a way that makes sense and we're getting high quality answers. And usually that involves people. So whether you're doing that with the help of government grants or with internships or with retraining, all those are possibilities to take what you have now and figure out, okay, how can we layer AI onto this to make better, quicker decisions that are still respecting data privacy and things like that. So for people to install their own servers in their own offices, basically going from the cloud back to on-premises, I think there's a lot of challenges that come with that approach.
And so to build on that one a little bit, do you see, like I'm assuming, there's an ROI based on the postgraduate programs that you deal with, MBA, etc. So I'm assuming there's an ROI attached to these deployments. I mean, if it's not for ROI, why would anybody do it? I mean, there must be cost-benefit analysis done that says, hey, if I invest in AI, these companies are going to be more profitable or they're going to be more efficient.
So if AI is basically a huge recycling machine and it can come up really easily with something it has a lot of examples of, think about things like marketing emails to clients. I want to write a personalized email to every single one of our clients. That would be an easy thing to build into a pipeline because I would say, hi, Robin, I saw this as your purchases last year. This is what we could interest you in now, and take all this data and customize it and send out an email or a letter to every single client. That would be complicated and technically difficult to do before, but with AI, it's become really simple to build that kind of thing out. And it has immediate benefits for the company. If we scale that idea, there's a million things we can do with AI. The problem is that if we're trying to come up with something brand new that it's never seen before, that doesn't exist, that's going to be very challenging because there's no examples of it. So if we're working in the world of things that are basically new copies in a slightly different context, we could build pipelines to easily put those out. And there's huge return on investment for investing in those technologies. A really good example is, especially in healthcare or other things, how do you communicate with your clients in their language for occupational health and safety, for training, for medical records, and all these forms can be built in a way that are localized, regionalized, have the right context, and people can understand.
So from a development, sorry, go ahead.
But my only point was, if we scale that to the next step, which was like, translated diagnosis and stuff like that, is that actually a good idea? Probably not, because you're going to end up saying the wrong words to the wrong person, meaning the exact opposite thing by accident. So that's where you really need a person, because it becomes much more high stakes than sending out a marketing advertisement.
And so, personalization is a big thing, and, in everything we do, emails, posts, social media, etc. It's really taken over. And you said, as you mentioned earlier, it's pretty easy. And one of the things I've, personally have been involved in, and it sort of touched me by heart, because I started my career as a programmer, and, that's like 40, 50 years ago, and, young kid learning in school. And I've done a little bit of coding early in my career through jobs. But then I stopped, and that whole thing, I forgot it. I mean, I don't know, like the stuff that I've learned in the 80s, it's done now. It's gone. It's expired aeons ago. So I went back to AI, and I just, I'm an old programmer. I like to get a refresher on this stuff. And, I was able to catch on to Python pretty quickly. Like I thought it was going to be a lot more complicated, but I was able to learn. So can you talk a little bit about that whole learning factor and upskilling, education, that kind of thing?
There's actually a term for this, vibe coding. You might have heard it. Karpathy came out with this term, vibe coding, and some companies are hiring vibe coders. Now, this is different than you because these are people with no background in programming. They don't know anything, right? Now, instead of talking about programming, let's talk about building a house. I want to hire a structural engineer, an architect. I want them to build a blueprint. Now, is it possible to learn the software to build a blueprint for a house? Sure. I can go talk to ChatGPT, learn how to use the software, build a house, no problem. In fact, you could take anyone off the street and teach them how to use the software iteratively, going back and forth with ChatGPT. The problem is that person not only has to know how to use the software, but they also have to know all the rules about building a safe house, building it with electrical, building all these other considerations in mind so the house doesn't fall down. Even though you have a blueprint, it still doesn't matter. Just like with software, are you building software because it actually works? Or are you building software looking at security vulnerabilities? Are you looking at software with developing using best practices, using the latest technology, and so on? So the challenge is that even though vibe coders can put together something, when they actually deploy the software, often it runs into huge problems because they don't have the technical basis underneath to understand how to do it or what's the best way to do it. And that's why people become software engineers. They learn the fundamentals of what it should look like and how you're supposed to put it together. Of course, that part can be really helped. Like, for example, I use Copilot from GitHub all the time, and it's kind of like my half brain. Unlike ChatGPT, it doesn't generate the code or the ideas for me. Just as I'm coding, I type in A = 1, B = 2, and it just finishes the rest of the alphabet because it knows the pattern of what I'm trying to do. It's like autocomplete in Word, but for coding. If you have no idea what you're doing and you're starting from scratch, even though you have AI, it means that you're going to build fundamentally flawed software. I think for education and training, it's fantastic. I have students now that are contacting me and saying, well, this was great, but I don't understand what ChatGPT is telling me. My obvious question is, you could ask ChatGPT to explain it to you, but instead you're emailing me. 2 years ago, I had students emailing me, asking me what the question was. Now, as far as what you're saying, I'll tell you an embarrassing story. A student wrote me a very long, technically complicated email with a whole bunch of problems that they're trying to explain. And I said, well, instead of retyping out the textbook, I'll just ask ChatGPT. So I said, answer all these questions. And it wrote out in really excruciating detail all the answers, why they work, how they work, and so on. I didn't realize at the very, very bottom of that email, the student also wrote, even though the semester's over, could I have an extension? And ChatGPT wrote back, sure thing, no problem. So I did read through the 4 pages of answers. I didn't read it too carefully. And when I sent it back, he wrote back and said, oh, thanks so much. And I said, great. Now I have to talk to my boss, and I ended up working everything out. It was okay. But the fact is that it's generating a lot of content that we may not be 100% aware of or look at. It changes the context of what we're doing. And I think that's a problem, especially when it comes to, new spam. It might be longer, it might be better written, but it's still creating massive amounts of spam that doesn't make sense. And I think that really having careful reading and understanding is key, because now I'm much more careful reading what the AI actually generates and making sure that it's actually right. So I'm saying the right thing. And sometimes it will take the wrong approach for a reason that I can't explain. And that becomes a really big issue when you're trying to scale that idea out.
That's right. And you know what? You bring a very good point, because a lot of times when you bring somebody to a new job, regardless of what it is, and they have no idea, they've never been exposed to it. I'm a construction worker and I'm going to fly a plane tomorrow. Like that shift, it is not, adjacent to what you're doing. It's not like you're, you're construction worker, you're laying out foundation. Tomorrow we're going to ask you to frame the house. You're still building the house, but different parts of the house. And your specialization is not that you're going to be like stretched to the maximum here. And you're right. Like, there was a conversation back when we were going through the transformation of that industries in general in Canada. We were talking about, converting oil workers to coders. I heard that many times on the news. And I was thinking in my head, like, how in the heck an oil worker is going to learn to code? Like, this is so diametrically opposed to what they're currently doing. It's not going to be able to be, shift their thinking from construction to coding. I don't know how that's going to work.
I think you have to have that domain expertise. And that part is really critical because it brings you could make sense of what's coming out. Again, just because I could use ChatGPT to design a house doesn't mean that it would be safe or make sense. It could be a blueprint, but that still would need to be checked by an actual expert. You mentioned before that we do have some regulated industries. The problem is that many AI tools are being developed for every regulated industry, whether it's law or medicine or nursing. And you already have cases where, they're making up court cases that don't exist because it's just coming out like that because they're using the cheap version of ChatGPT, which is a bad thing, right? So it has to be based on real, concrete, real-world knowledge. The problem is that that's not how AI systems work. So you end up having, working at cross purposes. It makes your job easier at scale, but less reliable. And that's a big problem.
Absolutely. Now, one of the things that we keep talking about throughout this conversation is that guidance, that the human needs to guide the output, guide the input, build a better prompt, learn to, give specific instructions to AI, because that general, translate this from English to Japanese, it's not really going to cut it anymore. You got to actually be precise. You got to give a detailed instruction. It's going to take you a little bit of time. It's not going to be like snap a finger and you're going to end up with an output. But if you think about what you're trying to instruct, your kid and telling them exactly how to go from here to the supermarket, how many steps they need to take, where to turn left, turn right, make sure they don't talk to anybody. You got to give all that instruction to build a good output. And people are lazy, I think. I mean, I don't know what it is, but I feel like people just want to type like one sentence and end up with a perfect output. I don't know how that's going to work.
So the big challenge is that let's go back a couple of years. You would tell the AI system, tell me the perfect recipe for ice cream. And it would tell you the recipe based on your prompt. People started talking about prompt engineering. The better your prompt is, the better the output's going to be. And what's happened now is we're getting into agent models as well as reasoning models. And in both of those models, what happens is I give a prompt, tell me about ice cream, and it starts thinking in the background. You can actually see that process on ChatGPT if you have a fancy one that starts saying, okay, I know they're talking about ice cream, but what are they talking about? And so what happens is your one prompt is actually generating 1,000 prompts in the background. So many prompts that you can't actually control what is going to come out at the end. So better prompt engineering isn't going to result in better output. It's just going to result in better thinking, putting thinking in air quotes because, it doesn't actually think, but it's going to try to build.
It's like you give a map to a treasure. Is that what I'm hearing?
It's building out more words to better describe the problem so it could, zero in on a better answer that's more highly associated. So imagine, the problem we talked about before, how many R's are in strawberry. Instead of just asking that one question, it built out a whole world of information around that problem and why it's a problem and how it works. Eventually, it would be much easier for the model to take that 2 pages of a material around this question and bring it down to 3. As opposed to just having to do a process in between it may not understand. So that's really what it comes down to, that as we get more removed from prompting and we get more into very complicated thought processes, it's going to become much more difficult. Sometimes this works better than others. There are new technologies that use agents to do work for you. They're still not there yet, but it is getting better, which means that it's going to really change how people use AI.
Yeah. And so based on what you're seeing from, your research and the domain that you're in on the academia side, I'm interested to find out, I guess we talk about it all the time, is, technology is evolving, but nobody can actually precisely specify the velocity of that evolution, right? So if we say, we're teaching, right now we need to guide AI into a better outcome, we need to keep an eye on it because this thing could be telling me things that are crazy. Where do you see on your side? Where do you see it going? Like, how far are we along? Are we going to get to a better AI in the next 6 months, a year, 2 years? Where are we at?
So this is a religious/philosophical question, and people have very strong opinions about this. But I'll tell you that
that's the superhero, is it?
Exactly. So people believe in something called AGI, artificial general intelligence. And if you've ever seen the Terminator, they're talking about Skynet, a computer that could think for itself, right? That doesn't exist. And we're very, very far away from that. In other words, we have a whole bunch of words, and those words are associated in different ways. That doesn't mean the computer is thinking. It just means that things happen in a certain pattern, right? Now, we could have fancier models that do more processing and better answers come out, because quite often the answer is bringing together a whole bunch of pieces of information that we could stitch together and make them work. When you answer a question that somebody asks you, you're basically taking your entire varied life experience, which is different for every person, and coming up with that cross-section answer, which, again, some people have a much better answer than others depending on the topic because of their life experience and training and pathways in their brain. AI models are not even close to that. Basically, AI now is like taking the processing of a cat and making it better. So there's two different pieces to this. One is we had this massive acceleration in software. We have these things called large language models. They could look at weights of words and find patterns. That's amazing, and it's been a game changer. We've tried to apply that to many different industries. On the other hand, we have not had a huge acceleration in hardware. So if you look at the past 2 years, we've had a 20-year acceleration in software, but we don't yet have AI on our phones. We don't have AI in our microphones. We don't have AI in our cars. So in our microwave. So that's something that's going to happen eventually and then start accelerating all of this. In the meantime, we don't have enough power to run AI everywhere in the world. So we're building data centers and new power plants to support this never ending. Now, the interesting thing is if you look at, let's say, answers or operations or procedure, sometimes those are very easy to come up with or process. Recently, Studio Ghibli pictures, people said, make me as an anime, and it almost melted down OpenAI. In fact, they put out a press release saying, please stop using our system because we're going to shut down if you constantly generate images. And that shows you that there's a problem. There's a mismatch between how much people want to use it, what they could use it for, and the real capacity that we have. Now, the real question is, what benefit does this give us, and does it scale? So if we keep on improving at the rate that we are, what's it going to look like in 6 months or a year? We're still not going to be at general intelligence, because the underlying fallacy is that if we make words better associated with each other, that's going to lead to new intelligence. It doesn't lead to intelligence, it leads to better recycling. So if we have a lot of examples, and currently we're at the point where all data that exists is pretty much in AI models, now what's next? Where do we get the better thinking? And there's jobs that people have training AI, and they'll keep on doing that. But to really have the next massive acceleration is going to take something new, either on the hardware side or on the software side, a different approach that we're currently taking. And we don't know what that is yet. So I'm looking forward to seeing what the next thing is. But I think until we have better processing and faster processing, it's going to be a very big challenge. Now, if you think about this in terms of a database or other data that's out there, processing hasn't exponentially increased in a very long time. I'm talking about like 40 or 50 years. We have new technologies like vectorization and other technologies to speed up databases, speed up data retrieval. But the reality is that AI uses some of those technologies, but still isn't faster exponentially than we've had before. The difference is now we're using exponential data, and we want answers faster. We want answers better. And we want to generate 25-page reports. And AI currently is incapable of doing that. So we'll see what happens.
Vectorization of data, man. I've heard of this like back in my days. Like this is nothing new. I mean, we're still at that.
That's basically what's happening, right? So, there are interesting ideas. Like somebody talked about quantum LLMs, but that doesn't exist. That's not a real thing. Right now, LLMs have to be kept in memory, all the different choices, and the system will choose between them depending on weights, as it has these different prompts inside of it that will basically guide which tokens to pick as it goes through the model. So there's not really much magic to it, if you want to put it like that. And the data speed and retrieval still requires a lot of processing to get to an answer. In other words, if you're going to do a simple database query, show me all the records in a table, AI is maybe 20 times more processor intensive, whereas explainable AI is 200,000 times more processing intensive. But it hasn't actually, that means that we have to have a 20 or 200,000 time faster computer to get the same performance that you can get today from SQL. I mean, that's an oversimplification, but that's basically the idea. We haven't really got to the point where we could make decisions that much faster because we're held back by current hardware.
Okay, so hardware is the limitation, and quantum computing, as you mentioned earlier, this is something that's come in to support that. But I am so, I'm
maybe that's actually not a real thing. That's a maybe.
Not a real. Yeah, I mean, that's a maybe. You put it in the bucket of the maybe. Yeah, that's right.
Exactly.
Now, I'm really glad that you're demystifying all this for us. To be honest with you, and because there's a lot of mystery around this, like it's a magic wand called AI that's going to solve everything. And from my conversation with you today, I hope my audience is come to the realization that this is a little bit more intense or a little bit more logical now, this picture that you're painting for us, than the what's on the street right now. Everything runs on AI, and you download AI and everything is fixed. It is not. I mean, back in my days when I was a DBA, I tell you, we still, apparently, I mean, based on what you're telling me right now, I didn't know that we still index data, we still vector data. It's crazy.
So if you think about it, AI, the system that we have now for generative AI, for text, is basically like fridge magnets, a huge collection of fridge magnets. Not those fridge magnets with words on them. You could mix them any way you want. They'll say different things. Usually they go together in certain patterns, and we can mix and match them to say things. But it's not more complicated than that. Like people who say, I'm going to feed in all of my data and get back all the answers are basically saying, I'm going to use a Ouija board to get to the answer, which doesn't really make any sense. That's not how it works. But for many of the things that we do, and I'm talking about the exceptional cases, but for many of the things that we do every day, I would say a large portion of the things we do are repetitive tasks that do have a certain logic in how we do them. And AI is great at imitating that logic over and over again and processing bills, creating statements for customers, writing resumes. Those are things that it has a billion examples of, and it can take real world data and generate those very quickly. That's a great example of how to use AI. If you're saying we should make more complicated decisions, my first question is, what training data was used to inform the pathway of why it's making that decision? Things like jobs, things like money, things like getting a mortgage. What data was it trained on? Why is it choosing what it chose? And that could be a really big problem if we don't really understand the biases that are built inside the data. Of course, we want things to be non-biased, and that means fixing the data or creating oppositional models, which, like we talked about before, may not actually work. So that really creates a question of how do we scale to quality? And I don't know if we can, but that is the goal of how we put all these pieces together.
Yeah. Now, two things left for this conversation. One is you mentioned that all the data, like the fridge magnet, all the data that's out there has been already consumed by AI. That's what I understood from that point. Now, what do you think of synthetic data? There's many businesses out there creating, okay, we need data, but we don't have it, so let's create it. And they're using AI to do synthetic data. And what's the pros and cons to that? And the second thing is data training. That's as a service. So people are creating services, and my company is one of them that I work for, Lionbridge. We provide that as a service to our customers. You have a bunch of data, you want them cataloged, categorized, annotated, whatever they need to be done, so you can use them into your models. That's where we come in. And the other part, which probably you mentioned earlier, is evaluating the output, validating it. Did it do what it's supposed to do, and what can we do to fix it on the inside? So let's start with synthetic data.
With synthetic data, like we run out of data, we need to invent new data because it doesn't currently exist. The real question is, does that synthetic data have the same internal validity as data in the real world? Sometimes there's patterns that happen inside the data that are very difficult to mimic, especially if we're just doing it on the surface level. For example, one of my colleagues had a group of numbers, and he wanted to invent some fake numbers, like, for example, utility bills, and the students would do some calculations and figure out inside those numbers what the coefficient is. AI isn't able to actually do that. It can create numbers, but they don't actually make sense after processing. It's really important to understand that processing, in other words, running the data on the computer, costs money. And AI models do not do that. They don't spend a huge amount of money processing or figuring things out. They're really working at the surface level. So because of that, even if you have really complicated data, it makes it very difficult to figure it out. I'll give you a really good example. I worked with a client that was trying to figure out how many sizes of clothes do we need? Like, do we need 5 sizes, 10 sizes, or something like that? Now, once you run out of real data, you could use synthetic data. However, all the internal measurements of every person against every other person and every size to find out the ranges of what works have to match. They have to be in the world of possibility so that you could build new synthetic people. That each line requires millions of processes or calculations to figure out if that actually makes sense, meaning it's very expensive for AI to generate that new real synthetic data. Of course, the AI can guess and can come up with approximate numbers that may not actually work. So that's a really big challenge. That where does synthetic data come from? Also, any previous data that was any previous biases that was in your real data might be amplified as you build out synthetic data. It will just continue the same patterns. That also could be a very big problem, because later on, we might not be able to explain why the model made the decision that it made. Imagine you had a model that was approving or denying loans, or approving or denying housing automatically, and we don't know why it's doing that, but the pattern probably comes from previously generated answers or previous data in our database. There's a technology called RAG, Retrieval Augmented Generation, where it uses our documents as a source of truth in order to build it out. That could have better answers, but it may just confuse the model and result in more bias or more uncertain information. So we don't really have a good solution for that yet in terms of training data endlessly. Now, what you can do is data annotation, where you take data that's normally not known what it is or what it's doing, and label it and say, here's an example of this, here's an example of that. Choose these when you use your model, and that's the work that you're doing. So you're basically putting new information or new human augmented generation into the model and telling it, here's new pathways you could be trained on. And that actually does have big benefits because it knows new things to pick from. Quite often, these are things that are not obvious, so they're difficult to synthetically generate at scale. Really, you need a person to say, this makes sense, this doesn't make sense. I give the example to my students all the time. Imagine you took every ingredient in your fridge. They would only go together certain ways that make sense, i.e. that you'd want to eat. You could mix every ingredient in your fridge, it would probably be disgusting. So there has to be some pathways, in other words, recipes, for it to actually make sense. Could those recipes be modified? Sure. Could there be tolerances where you could, change one thing for another? Certainly. But should we do that with every ingredient in the fridge? Probably a very bad idea. That would be gross, right? So we need something in between. We need a person to say, you know what? White wine, red wine, maybe we could switch those. Lemon juice, olive oil, maybe we could switch those. But other things you do not want to switch, right? That's the idea.
That's right. So synthetic data is, from what I'm hearing from you, is it's got pros and cons, depends on where you're using it, I'm assuming, right?
Yeah, it all depends on your use case and where it makes sense in your business, how you're trying to move data across a pipeline.
So my understanding here that you work directly with clients, is that what you keep referring to a client? And you're also on the Google group development, right? So you're part of that?
So through the Google Developer Group, I've been involved in it for 10 years. They have meetups across North America. We have, it's a bridge between industry and academia. And we have many students who are involved who later become industry professionals and work together to share knowledge and build new things. Although Google sponsors it, it's agnostic. So we have technology from many different companies. And it's really about building capacity and better connections in industry. So if you're in a city where it has a Google GDG, a Google Developer Group, I highly recommend joining it. It's really a really fantastic way to meet really cool people that you might not have access to otherwise.
Do you think a guy like me would benefit from joining?
Certainly.
Oh, yeah?
I think sharing your knowledge or learning new things and learning from people who are in industry, it's a great idea. I recommend it. They have them across North America, in fact, across the world. And you could meet really amazing people. I was at a GDG meeting last year, and I sat down with somebody who programmed software that's currently on Mars, like rolling around on the rover. He built it. When else would I have a chance to meet somebody like that? Right? That's amazing.
Absolutely. I'm gonna put it on my list of things to do. It's gonna be my next GDG meeting. I'm gonna be part of that. One last question before I'm cognizant of time here. Sorry for running over an hour, but one more question. I keep hearing about the AI and the footprint, the carbon footprint relation, and there's a lot of discussions around AI maybe negatively impacting environment and energy consumption. I'm thinking that's what they're referring to in that space. What's the read from your side on this one?
This is a huge problem because, like I said, AI is very processing intensive. And the more you scale it, like before, we talked about one prompt is 20 searches. But now your one prompt is actually going to turn into 1,000 prompts, and that's going to turn into the equivalent of 200,000 searches. So the amount of energy that you're using scales exponentially. And as we start developing more pictures, more text, more video, more multimodal AI systems, the demand for power and data centers and impact on the environment grows exponentially. How can we solve this? With faster, smaller computers, with faster, better software. And we've already seen a lot of movements over the past couple of years in both of those directions. So now in the future, we're going to have special made AI chips, which are more efficient and will ultimately help. The real question is, what's the value that we're getting for the amount that we're using it? If you pay $20 a month, is the amount of AI that you're using actually $20 a month? Or are you using $2,000 a month, but they're trying to give this to you? Companies like OpenAI are operating at a loss. Companies like Google and Microsoft can afford to run AI and lose money in the short term because they're going to bake AI into everything. So I think on a societal level, the question is, does this scale? Can we just keep on building AI and building AI for things that people could easily do? And is the cost worth it? And that's a question we don't really have an answer to. We know that AI has huge environmental impact as we build more power, more data centers, and so on. And really, I think it comes down to, what is the benefit? Should it be that we run local models or AI chips? And I think in the future, we're going to definitely see there's going to be a big environmental element to how much AI we're deploying and what it does. Does it actually make sense?
So in conclusion, what I'm understanding right now is we took an old concept of technology and wrapped it and put a better candy wrapper on it. And we called it AI, and we offered it to people. Thank you for demystifying that for me.
Yeah, ironically, there's a lot of AI wrappers now. I would say half the AI companies that are out there are actually using ChatGPT at their core and just building some new interface on top of it, but using that as the brain. Just like AI has taken like every English book and said, okay, what is the weights between all the words? How do they work together? And using that as its data source. So I would say that we're just wrapping multiple layers on top of each other without necessarily building something entirely new. I think that in the future, we're going to start looking at pathways and understanding them better and saying, what do we currently know? What don't we know? But there may be a lot of like intellectual fallacy there that we can generate new answers just by coming up with the right combination of words. In other words, you could read a fantasy novel like Harry Potter, but reading it doesn't make it true. Stuff in real life that you write about, that is true. Just like if you find something in the lab, you can go and write an article about it, but just writing about it doesn't actually create it. And that's the big existential question around AI.
Absolutely. I could talk to you forever about this topic. I'm so passionate about it, and I see you are. I want to thank you for taking part of this conversation.
Thank you very
Dr.
much.
Shapiro.
Thanks for having me.
I really appreciate it. And the audience, I'm sure they're going to enjoy this episode. It's the highlight of my month of recording here on the Localization Fireside Chat. I really appreciate you coming along. I hope you come again as this subject progresses and we have new elements of things to talk about. I'm sure there'll be
Certainly.
like every day there's a brand new topic that we need to introduce. And in the last thing here before we wrap up, Sidney, would you mind give us any last comments, parting wisdoms?
So I think that although this is very exciting, AI has been around for a very long time, like 40 years. And there's different kinds of AI, like, for example, machine learning. There's, many different branches, robotics, machine vision. And this generative AI is really new and exciting, and it has caught people's attention. So that's why everybody's talking about ChatGPT, but it's only one small part of this big AI universe. I think that people are more cognizant of AI now, and it's being rolled out in many more ways, and it's rapidly evolving. So just because something's true today, it doesn't mean that in a week from now or in a year from now, it's going to continue to be the same. And the amount of change that's happened, including new things like agents and new pathways and new kinds of AI and language models itself, have all just been developed in the really, really recent years and months. So I think it's important to stay tuned and stay updated with what it can do and see really how it could benefit you. What are the benefits to your business? How can it help you with your life? And what are the pieces that you could rapidly build out to get better advice faster and ultimately help you leverage what you're already doing?
Absolutely. On that note, I want to thank you, Dr. Shapiro, for joining me. I really appreciate it. I really enjoyed the conversation. I couldn't stop getting excited throughout this episode. I wear my heart on my sleeve when it comes to technology, and I get really anxious. But thank you so much for joining me. I really appreciate it. It was valuable time that we spent together. And for the audience, I want to thank you for listening in to this podcast. And if you're watching us on YouTube, I want to thank you also for watching us on YouTube. And if you're reading the summary, because I put out a summary on the blog for this conversation, there'll be another article put out there. If you're sharing that article, I really appreciate it as well. This is an initiative that is run by me. It's a personal initiative. It's not funded by anybody. So I really appreciate the support that the audience has been giving me. They're liking, they're sharing, they're commenting. I always hear success stories of people who listened to the podcast and they ended up getting a deal out of it, or they getting up, something positive came out of it in your life. I hope that contributes to that. And Dr. Shapiro, always welcome here at the channel. This channel
Thank
is
you very
yours.
much.
Consider it your channel anytime you have something to, and I love to support Canadian technology. So anytime you have something to tell us about, I hope you make this channel your location for that. Thank you again.
Excellent. Thank you.
And to the audience, I'll see you at the next episode. Thanks so much. And don't leave Dr. Shapiro. 1 second.